Hello everyone. Today we will discuss about the different variations of the Turing machine. To move about, we will first discuss that we have till now discussed about the deterministic Turing machines. Although Turing machines can both be deterministic as well as non-deterministic, but this happening of being deterministic or non-deterministic does not make them less powerful. We have already seen about the different parts of the Turing machine, that it consists of an input tape, a read-write head, whereas it also consists of the control, finite control, which will decide that whether the tape will go towards the left or towards the right or will not move at all. The tape is restricted so that you can only see a part of the tape with the input. Then the TM becomes less powerful linear bounded automata and can only recognize the context sensitive languages. We'll see to this particular part later on in our syllabus. Now, to be precise about this particular discussion, the Turing machine variations are equivalent to the original Turing machine. The different variations of the Turing machine includes the following: multi-track Turing machine, multi-tape, multi-head, multi-dimensional tape, and the offline Turing machines. We will come to each of these Turing machines in the next slides. The first type of Turing machine is the multi-tape Turing machine. A Turing machine with several input tapes will be called as the multiple tape Turing machines, and for each of the tape we will have their own read write head. Now in the case that it is a multi-tape Turing machine, we will call that each of the one, if we have n number of tapes for the Turing machine, m, then we define the first one delta q into x to the power n points to q into x to the power n points to L or R move to the power n. Now here is a diagram which will illustrate the two different for n equal to 2. That means in this case we will have two different tapes. So here you see for the two different, for n equal to 2 we will have two different operations. So in the first case, when the machine is in the state q0, we have the tape 1. For the tape 1, the read write head points to the first cell, and it reads a and it writes x while moving to the state q1. Similarly, for the tape 2, if we look that it is reading the input symbol e while it is moving one step towards the right, and it is one step towards the right after writing the changing from e to y. So this is the operation that it does. In one of the tape it can not move, while in the other tape it can write and move as well to the left or to the right. This is the occurrence of the multi-tape Turing machine. Next, we move on to the non-deterministic Turing machine. It is similar to the deterministic Turing machine, except the fact that for any input and the current state, it has got a number of choices. That means it will have, for a single input, it can move to n number of states. That means a string is accepted by the non-deterministic Turing machine if there is a sequence of moves that will lead to the final state. That means starting from a single the initial state, we have different moves in order to reach the accept state. In such a case, we will say it as a non-deterministic Turing machine. That means here you see, starting with q, after reading the input symbol x, we can move to 2 to the power q into x into L of R. That means non-deterministic Turing machine is allowed to have more than one transition for a single tape symbol. This is the difference of the deterministic and the non-deterministic Turing machines. Next, after this, we have the multi-head Turing machines, where for a single input output input tape, we will have different heads. Each head will independently read write symbols and moves to the left or right or keep stationary. That means for a single input tape, there will be two or more than two read write heads. This is the occurrence of the multi-head Turing machines. The next type of Turing machine is the offline Turing machine. It has got two tapes, which is represented as in the diagram. You can see that one tape is read only, that means it contains only the input, while the other tape is read write, that was initially blank, and as the input symbols are read from the input tape, the write operations are occurring on the read write tape. This is the occurrence of the offline Turing machines. Now we will move on to the next one, that is multi-track Turing machines. A Turing machine that has multiple tracks but a single tape head that reads and writes on all tracks. This will be called as a multi-track Turing machine. These machines accept recursively enumerable language just like single track Turing machines. Also, for every single track Turing machines, there will exist an equivalent multi-track Turing machines. It is moreover similar to the single track. It has got a match equivalence, and for a single tape it will read write on all the different tracks for a single operation. This is the multi-track Turing machines. We now move on to the next type of Turing machine, that is semi-infinite Turing machines. Such a machine have left ends limited to the left end marker and the infinite right end, where they also have two tracks. In the first case, we have seen that it has left end limited and the right end is infinite. It can also have two tracks, that is the upper track which will represent the cells to the right of the initial head, and the lower track that will represent the cells to the left of the initial head, but in the reverse order. This is the occurrence if it has one track and if it has got two tracks. In this case, the Turing machine will start from the initial state, that is Q0, and it will scan from the left hand marker. At each step, it will read the symbol on the tape under the head and writes a new symbol on the tape and shifts the head to the left or right one tape cell. The transition function will determine the action that is to be taken. The semi-infinite Turing machines can have two different special states, that is accept and reject. The accept state will denote that the input is accepted, while the other one denote that the input is rejected when the machine enters the state. In other cases, the machine will continue infinitely without any rejection or acceptance in certain inputs. This is the semi-infinite Turing machines. Okay, that is all for the time being. We will move to the next part in the further video.